Welcome to Solving Inequalities. We're going to look through here and we're going to figure out what methods we can use to solve different types of inequalities. So basically on solving a linear inequality, it's just like a linear equation. The only difference is these have the less than and greater than signs. When you're solving them, you solve them just like a linear equation, except when you get to that multiplication property, if you divide by a negative number, or multiply by a negative number, you have to reverse the inequality symbol. So let's practice. I have 3 minus 2x is less than equal to 11. If that was an equal sign in there, I would just start by trying to get x by himself, which means I would subtract 3 to both sides. The addition property. And I'm going to divide by negative 2 on both sides. That's the multiplication property. Oh, but looky there, I'm dividing by a negative number. Since I did, I had to flip the inequality sign to make it go the other direction. So according to this, my answer is all the numbers x that are greater than or equal to negative 4. What does that mean? Well, when we have an equation, we get one answer. That's like a point on the number line. In this case, if I look at the number line, and I'm just going to put a few numbers on here. At negative 4, I'm going to have, since it has an equal to, less than equal to, and greater than equal to, have an equal to, so that means it's going to be a solid shading that I'm going to do. So at negative 4, I'm going to solidly shade. And it says greater than, all the numbers that are bigger than negative 4 mean I shade this direction. Another way that you may have seen this written is at negative 4, since it is greater than, you have a bracket and shading. So just a brief reminder, if you have less than, then that's an open circle that shades to the left, or a parenthesis that shades to the left. If you have greater than, that's an open circle that shades to the right, or a parenthesis that shades to the right. If you have less than equal to, it's a solid to the left, or a bracket to the left. And greater than equal to is solid to the right, bracket to the right. Just a review of some of the things that you learned back in Algebra 1. Oh, wow, look at this linear inequality. The first thing I notice is he has fractions. So we're going to clear those fractions. Let's hope you remember when you had a rational equation that you cleared fractions by multiplying by the LCD. That's what we're going to do here. What does 4 and 3 go into? 12. That's the LCD that I'm going to multiply everything by. So I have x plus 3 over 4 times 12 greater than equal to x minus 2 over 3 times 12 plus 1/4 times 12. Now, did I flip the inequality sign? No, because I'm multiplying by positive 12. Now, let's clear those fractions. Remember, that's the cross-canceling. 12 divided by 4 is 3, so I'm left with 3 times x plus 3 greater than equal to. 12 divided by 3 is 4, so I'm left with 4 times x minus 2. 12 divided by 4 is 3. 1 times 3 is 3. Fractions are cleared. And then we start with distributing. So 3x plus 9, 4x minus 8. Combining any like terms, using our addition property to get all of the x's on one side. And all the numbers on the other side. So I get the solution that it's all the x's that are less than or equal to 14. So on my number line, I'm going to put 14 in the middle. And since it's an equal to, I'm going to put at 14 a solid dot. And again, this is x smaller than 14. So all the x's smaller or less than 14 are over here to the left. Another way to do that, like I said, was a bracket and shading to the left. Now, a compound inequality, you saw these in Algebra 1. They had 3 parts to them. Very easy to solve. You're just trying to get x by himself in the middle. So here's the middle of the inequality. And I want to get x by himself. So how do I do that? Well, I'm going to subtract 1 on all 3 parts. Negative 3 minus 1 is negative 4. 3 minus 1 is 2. And then I still want to get x by himself, so I'm going to divide by 2. Now 2 is a positive number, so I don't have to flip any signs. And now what it says is my answer is between negative 2 and 1 on the number line. All those numbers in between. So what does that look like? Well, let's see. Here's negative 2, negative 1, 0, 1, 2. Let's put some numbers on here. At negative 2, he does not have a line underneath, so he's an open circle. At 1, he does, so he's closed. And it's all the x's in between, so shade in between. Another way to write that would be a parenthesis and a bracket and shading in between. We call this conjunction when they are sandwiched in between like that for your answer. Now, absolute value inequalities, these are going to have absolute value bars along with less than and greater than signs. And they have some very interesting rules. If your absolute value is isolated and it's less than something, then you sandwich it in a compound inequality or a conjunction. If your absolute value when isolated is greater than, then you put it into a disjunction. All right, so we're going to start with, it's an absolute value inequality. We're going to start with seeing is he isolated. Yeah, it's all isolated on the left-hand side of the inequality sign. And then we move on to see what the sign is. The sign is a less than, so that means he's a conjunction. So that means that we take what's inside the parentheses, well, absolute value, and we sandwich it between the positive and negative of the number outside. So between negative 3 and 3. And then we solve that inequality. So I got to get x by himself, so I'm going to add 4 to all 3 parts. So that means that my answer is somewhere between 1 and 7. Which means since there's no lines underneath, that means at 1 and 7, they're open circles shaded in between. Or there'll be parentheses at 1 and 7. Conjunction. That's shaded or sandwiched in between. And that's the less than or less than equal to case that does this. All right, I'm going to try it another one. My absolute value, oh, he's already isolated, so that's good. Now I move on to the sign. It's a greater than. If it's a greater than or greater than equal to, it's a disjunction. The way I solve that is I take what's inside and put it less than the negative of what's outside, and what's inside greater than the positive. So greater than the positive, less than the negative. This is going to cause my function not to be sandwiched in between, but to go the opposite direction and be pointing outwards. Hence the disjunction. Just kind of cool. So we're going to start solving him. Minus 5. So we get negative 2x less than negative 12. Dividing by negative 2. Oh, look at that. I'm dividing by a negative. Over here. Divide by negative 2. Yep, dividing by negative 2 again. So I've got to flip that sign. Now, if I go to my number line, if I look at him, it says that it's all the x's bigger than 6. So open circle and bigger than 6. And all the x's less than negative 1. So open circle and less or smaller than negative 1. See how my arrows are pointing out? That's disjunction. If I was to use brackets on this, it'd be at negative 1 a parenthesis and at 6 a parenthesis. And this is only when we have the greater than or greater than equal to case. Again, after you've isolated, that's how you tell if it's conjunction or, in this case, just disjunction. All right, Neil, you try one of these in your interactive notebook. You're going to go on the left side of your page. You're going to isolate the absolute value. You're going to figure out, is he a conjunction or a disjunction? And solve him and graph him. Good luck.